for the pure paper 1, 2022 May, June, paper 11. Let's take a look at the first questions. For 1, let A be a positive constant. So A is positive. Use the method of differences to find the sums over here in terms of N and A. So for these questions, we know that we need to use the partial fractions. So we take this expression out. And do the partial fractions. So you'll get this. And when the R is equals to the negative A plus 1 over A, then you'll get this is a 0. Then the negative A minus 1. So your B will be negative 1 over A. Similarly, when the R is equals to the negative 1 over A, so you get 1 equals to this. Then your A will be 1 over A. Okay, so therefore, your series over here can be decomposed into two fractions over here, which is 1 over A or 1 over A R plus 1 minus the 1 over the A R plus A plus 1. Okay, so this is what you can start at the very beginning. Then take the 1 over A out. Inside here, if you put R equal to 1, you will get this. If you put R equal to 1, you will get this. Then when the R is equal to 2, you will get this. When the R is equal to 3, we'll get this. So you can see that they can cancel in such a way. So since we found the pattern of the cancellations, we can proceed until the last two terms. The last two terms, it will be 1 over the NA plus 1 minus a 1 over NA plus A plus 1. Then before that, it will be NA minus A plus 1. Then this one is a 1 minus the NA plus 1. So you can see that the pattern of the cancellations will continue like this until the last term. So you have the first term remain and the last term remain. Okay, so this will be the answer already. Okay, this will be the answer for the part A. There's no need for us to combine and become one fractions. If you want, you can actually make it like this. Okay, but this is something extra because the mark scheme allows you to leave the answer like that. So of course, if you worried, you can combining them together as one fractions. That one is up to you. So I will suggest to leave the answer like this will do. Okay, so this is the answer for part A. Now we move to the part B. So B now, if you look at the questions carefully, they change the n here become infinity. Okay, so this is given. which means that the limit of n going to infinity for the answer over here, you just copy this whole answer. So you get the 1 over the a plus 1 minus a 1 over the an plus a plus 1 is equal to 1 over 6. So when the n is approaching to infinity, this is affected. Your expressions over here will become 0. So you get this. Also multiply, you get a squared plus a is equal to 6. You get a squared plus a minus 6 is equal to 0. You factorize it. Then you get a is a negative 3 and a is equal to 2. Because the a is positive, you ignore it or reject it, then therefore your a is a 2. Okay, so this will be the answer for the part B. And now we move on. We have question number 2. Number 2, we have the point A, B, C that is given. The position vector look like this. Find the equations of the plane ABC given the answer in the Cartesian form. So what you need to do is I will write this in matrix form. See. So usually I prefer to write them in the matrix form. Then in order to find the equations of plane ABC, I need to find AB and AC. So for AB, just take the B minus A, you get negative x, 7, negative 5. For the AC, just take the C, OC minus OA, you get 8, negative 4, 2. So in order to get the normal vector for the plane, so I will just need to take the cross product between AB and AC. Just take the AB and the AC, we do the cross product. So you get this one as a negative 6i minus a 24j minus a 24k. So they all can be factorized and negative out. You get this. So that means I will make my normal vector of the plane will be 1, 4, 4. So your equations of plane ABC is given as the dot product over here. We have this as a random point, x, y, z. This is the normal vector. This is the normal vector. So for the last bracket over here, we can choose any position vector among the three over here. You can choose OA, OB, or OC. That is up to you. I will choose OA. So expand, simplify, then we get the answer. So this one we just expand it directly. 4 minus 16 plus 4. So it will be 8 minus 16 is a negative 8. Done. So this will be the answer for the part A. Just like that. So now move on to the part B. Find the perpendicular distance from a point to the plane ABC. So this one we just need to use a formula. Okay, we just need to use a formula. So the D will be equals to the equations. What is the equations of the plane ABC just now? This one is a y, yeah? I write wrongly. It's a y. Okay, so this one is the x plus 4y plus 4z. So x plus 4y plus 4z plus 8. Magnitude modulus divided by the 1 square plus 4 square plus 4 square. So since this point is its origin point, 0, 0, 0. So we just press the calculator, then you will get this one as x over 33. You can give the answer as x 33 over 33. Or you can give me the decimal point. in the 3 significant figure. Okay, so you can give to any one of these. You can give the answer in any one of these here. So this will be the answer for the part B. And now we move on to the part C. We have a point D that is having the position vector 2, 3, -3. And then we are looking for the line OD. So the line OD is actually R equals to this. So your directional vector is OD. So this one is passed through the point origin, the 0, 0, 0. So we can just make it become like this only. Okay. So that means the random point, it will be x, y, z, 2t, 3t, and -3t. We can have something like this. So I call this on equation 1. My equation of plane ABC just now was x plus 4y plus 4z equal to -8. I call this on equation 2. Substitute the variable 1 into the equation 2. So you get 2t plus 12t minus a 12t is equal to -8. Then you get that t is a -4. So when the t is a -4, what will be your the position vector? Will be changing all the t here become 4. You get 8, 12, and -12. 8, 12, and -12. Oh, sorry, it's a -4. Changing this to become -4. So the sign will be opposite, -8, -12, and +12. Okay, like this. So therefore, the position vector intersection point is equals to the -8, -12, and 12. Okay, that will be the answer for the number 2 C. So moving on, we have question number 3. Sequence of positive numbers such that the u1 is greater than 4 for n greater or equal to 1, and the un plus 1 fulfill this relationship. By considering un plus 1 minus 4 or otherwise, prove by mathematical induction that the un greater than 4 for all positive integer n. So what you need to do is just say that when the n is equal to 1, so your u1 is already given greater than 4 because from here. So the u1 greater than 4 is true already. True for n equal to 1. Assume true for n equal to k. That means that the uk is greater than 4. Now it comes to the third statement. When the n is equal to k plus 1, you have a uk plus 1 minus 4 as suggested by the questions. Just take the uk plus 1 minus 4. That will be equal to the uk squared plus uk plus 12 divided by 2uk minus a 4. Join them up as one fraction. So you get this as the -7uk plus 12 over the 2uk. Okay, because this one, I make it become 8uk over 2 if I want to combine these two become one fractions. So joining them, you will get this result. Okay, so over here, we can see that we actually can factorize it. What is our target? We're actually hoping to show that this is greater than 4. Then therefore, we hoping to see that this one is greater than 4. Okay, greater than, we're hoping to see that UK plus 1 minus 4 greater than 0. Therefore, we can show that the UK plus 1 is greater than 4. So what we can do over here, you can see that over here, this is positive because of your UK is greater than 4. Your UK greater than 4, that will guarantee you this one is positive. This one also definitely will be positive as well. Then this one also positive. So if all of them are positive, at the end, it will be greater than 0. Okay, so that means your UK plus 1 minus 4 is greater than 0. So your UK plus 1 is greater than 4 is true for n equal to the k plus 1. So now we come to the conclusion. By the BMI, okay, by the BMI, the sequence UN greater than 4 for all n greater than or equal to 1. Okay. Given that your UN plus 1 fulfill this relationship. Okay. So we just say like this, that will be enough. So now we move on to the question number 2. Question number 2 show this. So again, we will follow the method that we learned, follow the idea, not the method, follow the idea in part A. We want to show this less than 0, then we can show that it fulfill this. But these questions, we will not going to use BMI. We can see there's no mathematical induction. No mathematical induction. Okay. They didn't mention mathematical induction. So we actually no need to use mathematical induction to do it. We will just use normal way to do it. We just take the UN plus 1 minus the UN. UN plus 1 is UN squared plus UN plus 12 divided by 2 UN minus a UN. Again, combining them together, you get negative 2 UN. Okay. If you're combining them, this one had to make it become negative 2 UN squared over the UN, over the 2 UN. So if you're combining them, you get negative UN squared plus UN plus 12 divided by 2 UN. Factorize a negative out, you get a UN squared minus a UN minus 12 divided by 2 UN. Factorize it further, you can see that this one is a UN minus 4, UN plus 3 divided by 2 UN. So this one, it will be less than 0 because of your UN greater than 4. Okay, so you get this. Therefore, UN plus 1 less than UN shown. I forgot to write down for all. n greater or equal to 1. Shown. Done. That will be the answer for the question number 3. And now we move on to question number 4. The equations of 2x cubed plus 5x squared minus 6 equal to 0 has the roots of alpha, beta, gamma. Then they want you to find a cubic equation where the root is 1 over alpha cube, 1 over beta cube, and 1 over gamma cube. So what you need to do is to let y is equal to 1 over x cube. That will give you x is equals to the 1 over y power 1 of 1 over 3, or we can write it as a y power of negative 1 over 3. So your 2x cubed plus 5x squared minus a 6 equal to 0. Change your x to become this. Okay, change your x to become this. Then you get 2y power negative 1 plus the 5y power negative 2 over 3 minus 6 equal to 0. I think I prefer to multiply every one by y. So I get this. Then I separate the y with the power that is fractions, and power with integer. Separate them in this way. Cube both sides. If you cube both sides, then you get this. So this one is 125y. This one, it will be 216y cubed minus the 216y squared plus the 72y minus the 8. Simplify it further. So this is the new cubic equation that we have, that the root is made of 1 over alpha cube, 1 over beta cube, and 1 over gamma cube. Okay. So done for the part A. Number 4A done already. So now number 4B. Number 4B is we are looking for alpha power 6, 1 over alpha power 6, 1 over beta power 6. So this one is actually same as the 1 over alpha cube square plus the 1 over beta cube square plus 1 over the gamma cube square. So over here, or maybe we can look at them in this way. The whole thing here square, the whole thing here square, and the whole thing here square. So this will be equals to the 1 over alpha square plus 1 over beta square plus 1 over gamma square. Cube, sorry, not square. Cube. Minus 2 of this. Alpha cube, gamma cube, beta cube, gamma cube. Okay, so this is the formula. Okay, we just need to modify it to the formula that we usually use. We'll do. So this is actually, you can get this result from these equations. So you can see that from here, if you divide everyone by 216, if you divide everyone by 216, and if you divide everyone by 216, then you can see that your 1 over alpha cube plus 1 over beta cube plus 1 over gamma cube is equals to 1. This will be 1 over alpha cube beta cube plus 1 over alpha cube gamma cube plus 1 over gamma cube beta cube. Okay, so this is the result. So from here, we just take it out. This will be a 1 square minus a 2 of negative 53 over 216. Press the calculator, then you will get the answer as 161 over 108. So this will be the answer for the part B. Answer for the part B, yeah. So now we going for C. C, this one is actually 1 over alpha cube power 3 plus 1 over beta cube power 3 plus the 1 over gamma cube power 3. So what we can do is that we take from these equations. Okay. So we will be having the y cube is from A. Y cube is equal to the y square plus the 53 over 216y plus the 8 over 216. 8 over 216, we can simplify it to become 1 over 27. Okay, so we let the Sn is equal to the 1 over alpha cube power n plus 1 over beta cube power n plus 1 over the gamma cube power n. So from here, we will get S3 equal to the S2 plus 53 over 216 S1 plus the 1 over 27 S0. So S3 is equals to the 1 over alpha power 9 plus 1 over beta power 9 plus 1 over gamma power 9 is equals to S2. Where is S2? This is S2. This is S2. 161 over 108 plus the 53 over 216. What is your S1? S1 is just now. Okay, so just now the S1, this is S1. Okay, so it will be a 1 plus the 1 over 27 times 3. Again, press the calculator. You will get the answer as 133 over 72. Just like that. Done. That will be the answer for the question number 4. And now we move on. We have question number 5. The curve C has equations of y equal to the 2x squared minus x minus 1 over the x squared plus x plus 1. But A, show that the C has no vertical asymptote and state the horizontal asymptote of C. So what we can do is that to find the vertical asymptote, we let this one equal to 0. Okay, so the discriminant is the b squared minus the 4ac. It's a negative 3. Okay, so therefore we have no real root. And it will lead you to no vertical asymptote. Justify as shown. Okay, and then as for the horizontal asymptote, we just need to let I equal to the limit of x approaching to infinity of the 2x squared minus the x minus 1 over the x squared plus x plus 1. So you can see that when they go to infinity, you have only this 2x squared over x squared. 2x squared over x squared is a 2. So your horizontal asymptote is y equal to 2. So this will be the answer for number 5a. Move on. Find the coordinate of the stationary point. So for the coordinate of stationary point, we usually will dy dx it. So keep the bottom differentiate the top minus keep the top, differentiate the bottom divided by the bottom square. So simplify it, you will get 4x cubed plus 4x squared plus 4x minus the x squared minus the x minus 1 minus the 4x squared minus a 4x cubed minus a 2x squared minus a 2x plus the 2x squared minus a x minus a 1 divided by the x squared plus x plus 1 square. Simplify it, this one can cancel. So you get it's also cancel. 3x squared plus 3, 6x. This one also cancel. Square plus x plus 1 square. So to find stationary point, your dy dx equal to 0, which means that 3x squared plus 6x is equal to 0. Factorize it. Your x is equal to the 0 and x is equal to -2. So when x is equal to 0, what is your y? When x is equal to the -2, what is your y? Just put it back into the original equations using your calculator. We just direct write it out. The y will be a -1 and the y over here will be a 3. So therefore, stationary point are 0, -1 and -2, 3. That is the answer for B. So now we move on to the C. So for C, we need to find the sketch a graph and state the coordinate of the intersections with the axis. So we find the intersections of the axis first. So when the x is equal to 0, your y is equal to -1. Okay, actually, we already have x equal to 0, y equal to -1. Then when y equal to 0, you will get the 2x squared minus the x minus a 1 equal to 0. Factorize it. Then you will get this as a negative. Positive, you get x equal to -12 and x is equal to 1. So from here, I draw with freehand. Okay, I draw with freehand, so you just have to understand. So this one, you use a proper scale, 1, 2, and then 3, -1, and 3. So this one is a 1, this one is a -1, this one is a -2. Your horizontal asymptote is over here. Just now, what is our intercept? The set will be 0, -1, then -12, 0, and 1, 0. So it will be here, here, and here, your graph. And we're having a maximum. Maximum is a -2, 3. Maximum is over here. So we can see that your graph, it will be something like this. Okay, This one needs some practices. If you practice a lot, then you very likely you get the sense that the graph will look like this. So you can see that there's intersections of the curve with the horizontal asymptote. So over here, we need to spend one more part over here. When your y is equal to 2, so 2 is equal to the 2x squared minus the x minus 1 over the x squared plus x plus 1. So you get 2x squared plus 4 plus 2x plus 2 is equal to the 2x squared minus the x minus 1. So right here you will get your x is equal to 1. Hey, no, your x is a negative 1. So that means your intersection point here will be negative 1. Okay, so to show this. Okay, so this is your graph. Y, x, and this is the graph of y equal to the 2x squared minus x minus 1 over the x squared plus x plus 1. So that this will be the answer for the part C. Now we go for the part D. Part D, they want you to sketch a graph of a modulus of the graph just now. So modulus actually only this portion, it will be reflected up. So this one will be gone. So we need to do it one more time. So we sketch it over here. So we again with the proper scale. So this is a 1, negative 1, negative 2, negative half. This is a 1, 2, and then 3. 2 will be your horizontal asymptote. This is a 3, 2, 1. Maybe the 0 right over here. So your graph will pass through here, and pass through here. So this will be the maximum, reflect, and okay, so your graph will be something like that. Okay, so now over here for this portion of the graph, if you draw horizontally, you will get 4 solutions. Every line over here, you get 4 solutions. So from here, we know that our answer must be between 0 to 1. Okay, so in order to get 4 distinct real root, so that means your answer must be between here. Your k must be between here. Okay, so we just say that from the graph, your k must be between 0 to 1. No need to show any working, no working to be shown over here. Just need to from the graph that we will get this result. So this will be the answer for the 4D. And moving on, we have, not number 4, this is not number 5, this is number 5. So and moving on, we have number 6. Number 6. Polar curve equations r squared equal to the arctangent of half theta, where the theta is 0 to 2. Sketch the C and state in exact form the greatest distance of a point from C on C from the pole. Okay, so over here, usually we will draw the table to make sure that we can get more accurate, more systematic way to plot the graph. So this is the data, this is the R, 0, 1, and then 2. Okay, so just use your calculator. Remember, this one is radian. Okay, remember when you replace it, you need to use the answer in radian. Everything in radian. You might as well just change your calculator into radian mode. That will be easier for you. So over here, to save time, I just press the calculator earlier. So this one is 0.68. And this one is 0.89. Okay, so actually 1 decimal place is enough. You want to put it 2 decimal places also can. But because when we sketch a graph, it's not possible that we can plot more accurate than 2 decimal places. And usually 1 decimal place is good enough. So since like this, we will how to say, draw the polar graph over here. This is the data equal to the pi over 2. This is the data equal to 0. So when it's a 0 is here. So we actually need to find out the 1 and the 2 in terms of degree. So you can see that the 1 is somewhere here. And the 2 is somewhere here. If you convert them into degree, then you can understand better. So this is when the data is equal to 1, you get around 0.7 somewhere here. Then this one is a 0.9 somewhere here. So actually in between, you can see that your graph will start from here and then here and then here. So actually in between, it will pass through the center. I mean the data equal to pi over 2. So if you want, you can also add one more column over here to find the value when it's a pi over 2. Then you can find this answer to make your graph looks more draw it better in order to get a better result of drawing. Okay, so if you plot it like this, then you can get the graph like that. Okay, so this will be the answer for the number 6A. So now we move on to the 6B. Find the exact value of the area of the region bounded by the curve C and the half line of the data equal to 2. So that means we are looking for this area. We're looking for this area. So what is the meaning of half line? Okay, so data equal to 2, if you extend it, this is a full line. This is the full line. Okay, so if they say half line, that means I just only take half of it, like this, half line. So this is what it means by half line. Okay, so now what is the formula for finding the area? The formula for finding the area is half integrate from 0 to 2 r square d theta, just like that. So what is your r square? Your r square is a tangent of half theta. So we are having an integration that is involving inverse trigonometry function. So we know that we need to use integration by part to solve it. So integration by part. So you get this one as a theta arctangent of half theta minus the integrate theta multiplied by half of 1 plus half theta square d theta 0 to 2. 0 to 2. Okay. Then there's no rush for me to settle this. So I still remain it as a in terms of data. Over here, simplify it. You will get 2 theta over the theta square plus 4 d theta from 0 to 2. So from here now, we know that we can use the formula f prime over f to integrate. F prime over f to integrate. So right here, I will integrate it directly. This is what I get. Minus a ln of modulus theta square plus 4. Substitute 2 inside. You get 2 arctangent of 1 minus the ln of 8. Minus this. 0 minus the ln 4. Okay. So just use your calculator. This one is arctangent of 1 minus the half ln 8 plus the half ln 4. So we can, arctangent of 1 is a pi over 4. So this one is a half ln half. Okay, you can write like this, or you can write like this. Okay, so this either one, only the changes is positive and negative. Okay, so this is the answer for the number 6B. And now we go for number 6C. 6C is that we want to, sorry, so I think I missed out something. I just remember. Just now they're asking you to find the greatest distance of the pole on the C. Okay, so in exact form, okay, in exact form, okay. So when the theta is equal to 2, your r square is equals to the arctangent of 1 is equal to pi over 4. So your r max is equal to the square root of pi over 4. So this is what I need to show. Okay, the greater distance of a point C from the pole. Okay, or you can also write this as the square root pi divided by 2. Okay, yeah, almost forgot about this. So now we go back here. We want to find the furthest point from the half line theta equal to the pi over 2. So that means this is the theta of pi over 2. If you go for furthest, that means actually we are looking for the x d theta equal to 0. We're going for the x d theta equal to 0. So what you need to do here is we need to find out what is the x first. Okay, to find out what is the x. So what is your r square? R square is equals to the arctangent of theta over 2. We know that the x is equal to the r cos theta, but this is a square. So I need to square it. So I multiply everyone by cos square. So I get r square cos square equal to the cos square arctangent of half theta. So this is the x square equals to the cos square theta arctangent of half theta. So differentiate, implicit differentiation, 2x dx d theta equal to the keep the left, differentiate the right. Keep the left, differentiate the right. This one actually, just now we have to do it when we want to integrate to find the area. So this will be, okay. Then plus keep the right, differentiate the left. 2 cos theta, negative 2 cos theta sine theta. Okay, So if we simplify it, you will see that this one is the 2 theta over the theta square plus 4 minus the 2 cos theta sine theta arctangent of half theta. So in order to find the maximum, then from the theta equal to the pi over 2, you need to let your dx theta equal to 0. So that means the 2 cos theta over the theta square plus 4 minus the sine theta arctangent of half theta, it will be equal to 0. So the 2 cos theta equal to 0, or this is equal to 0. Either one. So what over here, we know that this one cannot be 0. Okay, because if this one equal to 0, your theta is equal to pi over 2. That will be not the furthest distance from the theta equal to pi over 2. So this one reject. We reject. So over here, that means we have left with only this. Left with only this to fulfill. So therefore, it fulfilled the result that we have. You just multiply everyone by theta square plus 4. Then you will get theta square plus 4 tangent of half theta sine theta minus the cos theta equal to 0. Okay. So shown. Okay. Now we have to verify one more thing. To verify, there is a root between 0.6 and 0.7. So we let this whole thing over here as a function of theta. Arctangent of half theta sine theta minus a cos theta. So we just need to use our calculator, change it into radian mode. Okay, so we just try the check f0.6 and f0.7. So to save time, I have calculated this earlier, but you have to practice on how to pressing the calculator yourself. Okay, so you can see that there is a changes of sign. So just say that because of there is changes of sign between 0.6 and 0.7. Therefore, the equations has a root between 0.6 and 0.7. Verify. Okay, so this is how you verify it. So this will be the answer for the question number 6. And moving on, we have question number 7. 3 by 3 here, like this. And then they wanted to find a set of value k which the a is not singular. So for not singular, the determinant of a must not be 0. So we just know that this must not be 0. So how do you find the determinant? It will be 9k minus the 48 minus the 2 of the 36 minus the 42 plus the 3 of the 32 minus the 7k not equal to 0. So at the end you get negative 12k plus 60 is not equal to 0, and then you get your k is not equal to 5. So this is the answer for the part A. Now we move on. A is not singular. Find in terms of k the entries of the top row of A inverse. So actually we need to know that the A inverse is actually 1 over the determinant A of the C transpose. So C transpose is actually you need to find the cofactor of the A and then you transpose it. So that means we need to find the minor for this, and this 3 value. Okay. So I copy down let me copy down the matrix A first. So the matrix A look like this: 147, 2K8, and 369. So first of all, we find the determinant of A, which is a negative 12K plus 60 from just now, the part A. You can see that actually they're having a common factor. You can take the 12 out, you have a 5 minus K. So we need to find the transpose. So for the first element, it will be 1 over the determinant. You take this, you cover it, then you have a K 869. So you get 9K minus the 48 divided by 12 of 5 minus K. Simplify it further, you will get 3K minus 16 divided by the 4 of 5 minus K. So this is what we have. Then the second, the first row, second element. So over here, have to be careful. There will be a negative here. So you just take the element here. So you get 2839. Then you get 18 minus 24. 18 minus 24 is negative 6, so it's positive 6. So you divide the 6, cancel the 6, you get this. So that is the second element. And the third element is 1 over 12 of 5 minus K. This time is you cover this up. So the rest of the 4 that remain not yet covered by the line, it will be this. So this one will be 12 minus 3K over this. Simplify it, you get 4 minus K divided by 4 or 5 minus K. Done. This will be the answer for the part B. And now we move on to the part C. So part C is that we know that this is what is the dimension? This dimension is 2 by 3. This dimension is 3 by 3. So what is this dimension in order to get the 2 by 2? So this is the same. And in order to find the dimension of C, these two has to be the same. So the M is a 3. M is a 3. And in order to get 2 by 2, the N will be a 2. So C is a 3 by 2 matrix. Okay. C is a 3 by 2 matrix. C is a so we let C equals to the A, B, C, D, E, F. So the BAC is equals to the 2K1. That will be 100100 multiplied by the matrix A, 147, 2K8, 369, multiplied by the A, B, C, D, E, F. That will be equals to the 2K14. So we can just multiply these two first. So if you multiply these two, then you will get this one as the 1, 2, 3. And then 4K6. Multiplied by A, B, C, D, F. So if you multiply further, you will get A plus 2C plus 3E, B plus 2D plus 3F, and 4A plus KC plus 6E, then 4B plus KD plus 6F equal to the 2K14. So you can see that it's very obvious you can compare this. By comparison, okay, so you can see that in order to get K, your C is a 1. So if your C is a 1, then your A is a 0. E is also 0. So if it's this case, then you can double check again. Actually, if you put this value, you can fulfill the 2 as well. So it's very obvious that the C is a 1, A is a 0, E is a 0. By comparison, we just say that the A is a 0, C is a 1, and E is a F. E is a 0. So now we do the same thing again. We compare here and here. And then we also compare here with here. So you can see that if I let the B equal to 1 and the rest equal to 0, then my problem solved. So from here, therefore, your C is actually equals to A, B, C, D, E, F. That is your answer for the question C. Done. So now we move on to the question D. Find a set of values of K which the transformations of XY plane represented by the matrix here has two distinct invariant lines through the origin. Okay, two distinct invariant lines through the origin. So right here, we just need to let our invariant line is y equal to mx, no c. Then your image, it will be y equal to the mx. So transform the xy to become xy. And you will get 2k14 of x mx equal to the x mx. So if you expand, you will get 2 plus mx equal to x, that will be my first equations, and k plus 4mx is equal to the mx. That will be the second equations. So take the first equations divided by the second equations. We will not going to consider the case where the x equal to 0. So you can assume that the x not equal to 0. Do the cross multiplications. Then we have a m squared minus a 2m minus a k equal to 0. So in order to have the solutions, your discriminant must greater than 0. That means your negative 2 square minus a 4ac must be greater than 0. So it will be 4 plus 4k greater than 0. Your k must be greater than negative 1. But there's a tricky part over here, because we do not want our determinant to be equal to 0. Okay, the determinant of this matrix cannot equal to 0. So your determinant not equal to 0, that means x minus k not equal to 0. So therefore your k is not equal to 8. So therefore your k is greater than negative 1, but the k cannot equal to 8. That is all. So this is the answer for the question number 7D. And this will be the last question for this paper. So I will stop the video here. I'll see you next time, and